going to do is we are going to create this environment, and right now what I'm going to do is I'm going to do everything in vSAN 1. And the reason I'm going to do everything in vSAN 1 is the fact that I don't want to confuse the mechanisms that go into creating this environment. Ultimately, we're going to create different vSANs. Now, understand a few things here, and that is that this network is actually two separate configurations. Notice there's no interconnection between these devices. This is, again, restoring the concept of a SAN island. So I have two SAN islands in this scenario. It's just important to understand that these SAN islands are going to be carrying vSAN traffic at some point. In the very beginning, we're not going to worry about it. We're going to use vSAN 1, which is the vSAN that every interface is going to belong to, and it's also a vSAN that we cannot delete. We can suspend it, but we can't delete it. Now, we mentioned a few things that I want to highlight before we move into the rest of the configurations. So, of those things, the first one was we noticed, or we talked about the fact that we had initiators, and we also have targets. Now, initiators and targets are going to connect to our switch fabric. So if I have switches, let's just say, for the sake of argument, I have two switches. So let's say I have the 9222i and I have the 9134 that I'm using. These are all MDS switches, and I want to connect the targets to this switch. So let's say, for this instance, this is my JBOD, and let's say this is a Windows 2012 server. So let's see, Win 2012. Now, these devices, this being an initiator, this being a group of targets, are going to be called in ports. Now remember, we said in port meant node port. Node ports connect to these switches, which are physical manifestations of my fabric, my SAN fabric, via F ports. F ports are fabric ports. So every port on this switch, until I do something with it, i.e. connect it to another switch, is going to be some variation of a fabric port. Now, the moment that I connect two devices together, this is an F port, we get what we call an E port. That E port, again, stands for an expansion port. Expansion ports are ports that are going to take what was at one time two fabrics, and it's actually going to transform them into a single fabric, so one fabric. Okay? Now, this is single fabric design. It's just everything is in a single fabric that we call vSAN 1 in Cisco. Now, the moment that I have more than one vSAN, so let's say over here I have this target is in vSAN 100. This initiator is in vSAN 100. And let's say I have two other devices. Let's say I have a second target that is he's an in port. He's going to connect to an F port, but this interface is going to be in vSAN 200. And I'm going to have another Windows 2012 machine here, which is going to be an initiator connected to an F port, but this port is going to be in vSAN 200. Now, using this concept, I would need to create a link, an E trunk or an E port between these two in vSAN 200. However, if I had 30 vSANs, that means I'd have to have 30 individual links. So what ended up happening was they took this idea and they said, well, this just isn't practical or practicable. And what they did is we're going to say, well, we've already got this concept of a trunk in routing and switching that can carry multiple VLANs. So what we'll do is we'll borrow that. And what we're going to do is we're going to have the ability to be able to send traffic in multiplexed configurations across this link like so. And what we're going to do is we're going to use the vSAN tag to keep the traffic separate. And what we're going to do is we're going to say, well, this means we're trunking vSANs across this link. So what we're going to do is we're going to call these TEs, trunking expansion ports. And this is going to be the idea of virtual SAN devices. So now what ends up happening is that I have the equivalent of this switch pretending it's going to be two switches, this switch pretending it's going to be two switches, and I have a link across between the two that can carry multiple vSANs across that link, which is called an E or expansion port. Another name for this is an ISL, an inter-switch link, sometimes referred to as an EISL, an expansion inter-switch link. But keep in mind, the moment I have vSANs, I now get this idea of trunking. Now, the reason that I'm bringing this up is that we need to also look at the control plane. One more time. The control plane is going to be the way that we register with the traffic or with the fabric itself. Fabric registration is the principle of SAN networking. Fabric registration allows us to be able to go well beyond what catalyst style switches can do, because the catalyst switches, so when we look at LAN or local area network switching, we do what we call flood and discovery. Where in SAN, everything is stateful. Everything is handled in a stateful fashion. Well, what are those control plane mechanisms? We've already talked about them. The control plane mechanisms that we're going to be discussing, I'm going to go back to my sheet. The control plane mechanisms in traditional networking is going to be defined as, so control plane mechanisms are going to be what we called the fabric login, which is referred to as a floggy. And that's a fabric login is going to be where a initiator or a target is going to register with the fabric. Now, by fabric, I'm talking about the switch that it's connected to. Now, the other mechanism here is that we also have what we call a port login, referred to as a ploggy. Now, the ploggy is going to be when a initiator or a target registers with the principal switch. So that begs another question. What's the principal switch? The principal switch is responsible for maintaining a database. That database is referred to as the fiber channel name service database, the FCNS. Now, that begs another question. Well, what is the nature of these particular processes? So if I do a floggy, I create a database. But that database is local to the fabric switch. The ploggy, however, is going to be created by the principal switch, but it's going to be distributed to all switches in the fabric. So again, there's a lot of moving parts to this process, and these are things that I want to be able to work with. But the single most important thing that we need to understand here, and I'm going to put that in red, is the fact that as we look at this, we have a floggy, we have a ploggy process per vSAN. And it's also important to understand that we have a FCNS and floggy database per vSAN. So everything with regard to these control plane mechanisms are going to be considered vSAN centric. Now, I said we were going to start making things live, and the best way to be able to do that, like I said, is going to be to try to cement these logical concepts onto our equipment. So that begs the conversation again. This is our connection. So I'm going to start with MDS1, and on MDS1, the first thing that I'm going to do is I'm going to bring this device up, and I'm going to activate this port FC1/18, which is going to connect to my fiber channel storage array. I want to observe what happens the moment that I bring that interface up, and I also want to observe the creation of those databases just one more time. Now, again, like I said, storage is the newest concept for the majority of us that are looking at data center, and I want to make certain that it's old hat by the time we get to it. But what